All right, guys, in this video, we are going to do the last lesson of the first semester of calculus. And we're going to go back for a second to our study of limits. So when we were doing limit problems, we analyzed problems like the limit as x approaches 2 of x minus 2 over x squared minus 4, or the limit as x approaches infinity of this problem right here, where we have, if we were approaching infinity, we looked at the horizontal asymptotes, but if we had equal degrees, the asymptote was the coefficients. So what we're going to do is we're going to take a look at these a little bit further. So in this first limit, if we plug in x equals 2, we get 0 over 0. And in the second limit, if we plug in infinity, we end up with negative infinity over infinity. Okay, even though we know what the answer to this one is, let's pretend we don't for a second. If you do plug in infinity, you end up with negative infinity over infinity. Both of these forms, this form of 0 over 0 and negative infinity over infinity, those are called indeterminate forms. And the issue with them is that we can't quite determine, it's not clear what is happening in the limit, okay? It's not quite clear what is happening to y as x is approaching some number. So you can read the rest on your own. But I want to take a look here and show you that there are 5 additional indeterminate forms. Besides 0 over 0 or infinity over infinity, there's also different types of indeterminate forms. I want to go over them even though they're not going to be on the exam, the AP exam. We're really only going to deal with these types of indeterminate forms. I just want to show you so that if you ever take another calculus class in the future, you might encounter this again. So another indeterminate form is when you have 0 multiplying to positive or negative infinity. Why is that indeterminate? Well, because you learned that 0 times a number is always 0, but infinity times a number is always infinity, so we have a conflict there. So I can't determine, it's an indeterminate form. How about infinity take away infinity? You've learned that x take away x is 0, so a number take away himself is 0, but infinity technically isn't a number, so that's a conflict. 1 to the infinity. You've learned that 1 to any power is 1, but x, some base, to the infinite power is infinity, so that's a conflict. 0 to the 0 power is also indeterminate form, because 0 to any power is 0, but x to any 0 power is 1, so we have a conflict there. And infinity to the 0 power. We learned that infinity to any power is infinity, but x to the 0 is 1, so we have a conflict there. So these are also called indeterminate forms because we don't know what's going on. We have a conflict. But for the AB calculus exam, new in 2017, okay, you are only responsible for knowing how to deal with limits that end up in this indeterminate form of 0 over 0 and infinity over infinity, okay? There are some techniques that you already knew how to do without the rule you're going to learn today. For example, if you had this problem without L'Hopital's rule, which is the rule you're going to learn today, you simply would factor the bottom and you would cancel and then plug 2 in again. In this one, we did our horizontal asymptotes rule, so this was equal degree. So the answer is negative 5/3. But what about situations where you can't do that? Or what about situations where, you know what, you don't really want to do that because it's much faster to do the rule? Either or. We have a rule called L'Hopital's rule. So here's what L'Hopital's rule says. It allows us to evaluate limits involving indeterminate forms. So let's say you have the limit as x approaches a of f of x over g of x, and you get 0 over 0 or plus or minus infinity over plus or minus infinity. Where a can be any real number, a can be infinity or negative infinity. So that little guy right there, a, it could be a number, it can be infinity, or it can be negative infinity. If you plug it in and you end up with 0 over 0 or infinity over infinity, then the following is true. Then the limit as x approaches a of f of x over g of x equals the limit as x approaches a of f prime of x over g prime of x. F prime of x over g prime of x. So let's take a look at this example. So this is easy. This is easy, okay? Let's take a look at this first example. The limit as x approaches 2 of this rational function. If you were to plug 2 in, you get 0 over 0. You can try and factor this out, or you can just do L'Hopital's rule, which is the limit as x approaches 2 of 6x, equal to, this is the same as, the limit as x approaches 2 of 6x minus 7 over 1, okay, which is taking the derivative of the numerator over the derivative of the denominator. Let's plug in 2 again. So the limit as x approaches 2 of 6x minus 7 is equal to 12 minus 7, which is 5. Okay. In number 2, the limit as x approaches negative 3 of x plus 3 over this square root of x squared minus 5 minus 2. We would, at this point, I'd be looking down here to do a conjugate, and there's going to be just a lot of algebra involved. Well, first I'll check to see if it's an indeterminate form. So 9 minus 5, that's 4. Square root of 4 is 2. Minus 2 is 0. And we have 0 over 0. So that is an indeterminate form. So what you'll want to do is take the derivative of the top. So it equals the limit as x approaches negative 3 of 1 over the derivative of the bottom, which you have a chain rule down there. So let's do that chain rule. That's 1/2. I don't know why I'm not able to write on here today. Okay. 1/2 x squared minus 5 to the negative 1/2 times 2x. So 1 over 2 times x squared minus 5 to the 1/2, or times 2x. And then we'll try plugging in negative 3 again. So if we plug in negative 3 here, square it, that's 9, minus 5, that's 4. The square root of that is 2 times 2. So we have 1 over 4 times 2 times negative 3. 1, 2. So we've got 1 over negative 3 halves, which is equal to 2 over negative 3. All right, check my math on that. 2 over negative 2/3. But according to the answers, I am correct. So the process is not complicated. If you end up in indeterminate form, if you end up in 0 over 0 or infinity over infinity, you're going to run L'Hopital's rule, which means you're going to run the limit again as x approaches a, but instead of f of x over g of x, it's going to be f prime of x over g prime of x. So I would like you to do the rest of these problems. Okay. And that will, that's it for L'Hopital's rule. So that is how you notice it. If it's 0 over 0 or infinity over infinity, you can apply the rule. It'd be interesting if some of you took some kind of like, I don't even know, took a lead and said, you know, maybe researched why does that work? Why does L'Hopital's rule work? And I'd be curious to see what you come up with. Why does that rule work? If you're interested in checking that out, do that and maybe type something up for us or share something with us in class. Okay? That's all I have for you. Let me go ahead and grab a joke for you. So here is your joke. And hopefully that doesn't happen in our class. But there's a little funny for you. And have a great rest of your day.